Hey guys, we're going to talk lesson 7, order of operations, when we're talking about operations on expressions. In our entry task, consider the expression x squared plus 5x minus 9. I like to take the x squared terms and rewrite them. I don't always do this, but it does help to explain what I'm doing right now. List all the terms which are alike. These are alike because they have an x squared. The terms with 5x and minus 5x, those are also alike because the exponent is different for these x's. This technically has a hidden 1 exponent. And so x squared, which means x times x, and 1x, which just means there's only one of them, little arrowhead, that x squared is not the same as just x by itself. So therefore, this is a pile of like terms, and this is a pile of like terms. There's one more pile of like terms. There's the 2 and the minus 9. These don't have x's on them. Well, I mean, technically they do. X to the 0 equals 1. So technically 2 is the same as 2 times x to the 0. But we don't need to necessarily put that at all. So 1, 2, 3 like terms. What I did by grouping is what you should do when you add polynomial examples. We look for things with the same variable and the same exponent. So 4x squared and 2x squared are added together. X and 3x are added together. Again, x squared is not the same as x, so everything with an x squared is combined. They are like terms, or equal, similar terms. Things without x's, these constants, the 7 and the 1, those are added together. Now the way that you can think about this is you can just focus on only the 4 and the 2. 4 plus 2, which is 6. And then because these were x squared things, as in x squared plus 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 x squared, that means there are 6 x squared terms. X plus 3x makes 4x. And then 7 plus 1 makes 8. And so there we have it. This is what you achieve when you add these two polynomial expressions. BT dubs, a polynomial is an algebra expression where you have variables, you have coefficients, and they're added or subtracted or grouped together. If we look beyond this one, now I've changed the exponent on purpose. So I wanted this question to be here to talk about it. This minus 3x squared does not have anything similar to it. So we just bring it down. This 7x squared has nothing similar to it. 7's positive, so we're going to throw in a plus sign. 6x plus 2x makes 6 plus 2, because you add the coefficients, another vocab word. They are the numbers in front, numbers showing how much / many of something, like 2x. It means 2 x's grouped together. So 6x and 2x, we add the coefficients to make 8x. And then last of all, minus 4 and minus 2 make minus 6. So there is our expression. Okay, would you go ahead and do the adding polynomial exercises? This is extra practice. If you want your points, you need to do these problems. I'm going to go to the next page. Subtracting polynomials is another challenge. And the reason that we have this one and it's mentioned after addition is to think about what you do with that minus sign. I'm going to fully explain it, and then I'm going to show a shortcut. So Remember this fact. 6 minus 2 is 4. You know this. You know this since you were in first grade, I hope. And the same is true if you say 6 plus negative 2. That equals 4. So when I see a subtraction symbol, I can remember that it is really adding the negative of a number. And in this problem, where I have a subtraction right there, I can rewrite this whole thing, 10x squared plus 3x plus 7 plus negative 1. There's technically a coefficient of 1 right here, but 1x is the same as just not even writing a 1 at all and just writing x. So we don't typically see or necessarily have to put a 1 in front of that pair of parentheses. 2x squared plus 3x plus 1, writing that completes the expression. Then, remember what we did in the previous lesson, we used the distributive property. So this minus 1 is going to be multiplied or distributed to everything to the right of it. So we have a rewrite, 10x squared plus 3x plus 7. Notice that I've dropped the parentheses because as soon as I start using a plus sign, the parentheses aren't even necessary anymore. Minus 2x squared minus 3x minus 1. Because this negative 1 takes this positive and makes it negative, takes this positive and makes it negative, takes this positive and makes it negative, I don't want you to think that's an equal sign, that means that all of these are now subtracting, subtracting, subtracting. So we have 10x squared minus 2x. 10 minus 2, 8, and then there are x squared of them. 3x minus 3x, that's actually going to cancel. It's 0. And then 7 and minus 1 makes 6. So there's our expression. A shortcut, you can do a shortcut if you take this negative and you see how I just distributed by multiplying negative 1 to 2 to 3 to 1, and it made the 2 change from positive to negative, positive to negative, positive to negative. That means that this negative is going to make that negative, that negative, that negative, and that positive. Because a negative times a negative is a positive. So I rewrite 3x to the third minus x squared plus 8. I don't need parentheses because in distributing the negative, I now have a plus negative x to the third. So that's that one and that one. Minus 5x squared minus 4x. But because I distributed, I don't need that parentheses or grouping of parentheses anymore. Now I can just put things together. 3x to the third plus negative 3x to the 3x to the third plus negative x to the third makes 2x to the third. Cross them out. Negative x squared minus 5x squared makes negative 6x squared. Cross them out. There's no other x's over here, but there is a minus 4x, so I'm going to write x to the third, x squared. Technically, it's x to the first, and then that puts the proper order for writing down all of your numbers. And then let's see, we have 8 plus 7. There we go. So you can either write a negative as plus negative 1. That's okay. And then you can distribute. Or you can just take the negative and distribute. And things that were positive become negative, become negative, become negative. Things that are negative become positive. Okay. Extra practice. Extra practice. Please do the, well, remember we said process for subtracting. I mean, this concept. Put that in there. Please do the learning targets and success criteria. Rate yourself. Give me the how can you improve. Try to be more creative than more practice. Because are you actually doing this? Are you actually putting in the extra practice? If you're not, who cares? You're not doing what you need to do. So try something else right here. Like I will actively seek to understand what is going on. Whatever, I'm not going to give you everything. This is a quiz question. Hint, hint. Please do it. And then last of all, yes, you need to do the problem set. Okay, thank you and goodbye.